Welcome to the fourth of 7 lessons in assessing the accuracy of remotely sensed data. Last time we talked about positional accuracy. There were 2 lessons on that, and now we're going to have 3 lessons on thematic accuracy. This is part 4, and it's an overview of thematic accuracy. I'm Russ Congalton, and thank you for joining us today. So the objectives of this lesson are 5-fold. First, we're going to make sure we define accuracy assessment, including some examples. Then we're going to discuss a little bit of a historical perspective and talk about some traditional beliefs that you might have to overcome. Then we're going to document why one does an accuracy assessment. We're going to make sure we understand the error matrix very completely, including some examples. And then we're going to look at the steps in the accuracy assessment process. So let's move on. So what is thematic accuracy? So again, the Glossary of Mapping Sciences, published by the American Society of Photogrammetry and Remote Sensing and others back in 1994, say the difference between a specified value of a particular quantity. In this case, it's going to be a theme or a land cover, right? And a value that has been accepted as correct for that quantity. In other words, we're going to compare what's going on the map classes, to what's going on something that we're calling the reference data. And remember, we're not using the term ground truth here. So that's pretty straightforward. I think the examples make it very easy to kind of see what's going on. So from a historical perspective, it's really important to, just have a little history here. And back in the old days, aerial photography coming out of especially World War II, lots of people trained in aerial reconnaissance, and it was sort of a time-honored skill. If you've done any photo interpretation, you understand that it's a skill, it's an art. You get better and better at it as you practice it. And the need for going to the ground was well understood. People went to the ground, compared what was going on the ground to what was going on in the photography, and kind of trained themselves to recognize those things. But any idea of a quantitative assessment was really not part of that. Okay, the ground checking was to make sure you were right, and maybe improve your understanding, or if you had some kind of confusion going on, but it was never done independently as an assessment later on. Okay, then along came the digital data. And when we had digital data, of course, the first thing we wanted to do, in the early 70s, we got Landsat 1, and everybody says, well, how good is this? Okay, and so what would you compare it to? Well, you would compare it to the aerial photography. So that assumed that the aerial photography was the reference data, and assumed that the aerial photography was significantly better or more accurate than the satellite imagery. And that's not always the case. Okay, sometimes you can do that, and sometimes you have no choice. But it was really kind of unfortunate, because the poor Landsat satellite back then got blamed for inaccuracies that were really a function of some poor reference data generated from aerial photography. So I kind of look at it as that we have 4 different histories, or 4 different ages, or if you want to call them epochs, you can call them epochs for accuracy assessment. Early on, when people get very excited about a new technology, they go and go, hey, this looks really good. And, oh, I produced this map and it looks good. And it looks good is good. You want it to look good, right? We talked about some qualitative assessment, logical consistencies and completeness. Those things make the map look good, and you want them to look good. Okay, but it's not sufficient. It's a necessary condition, but it's not a sufficient condition. And then we moved on from there to some non-site specific assessments. And what we're talking about here is not looking at a locational component, but doing averages or over a certain area kind of situation, but not specific. And that didn't last very long. And people said, well, we really need to know how we're doing in this location and how I'm doing in that location. And that got us into the site-specific assessment age. And now, for a long time, we've been in the error matrix age, where we're using the error matrix as our quantitative measure of seeing what's going on as far as thematic accuracy. Okay, it'd be time to, I think, move out of this age if somebody came up with a more clever way of doing this, but at this point, we're still using the error matrix age. There are some traditional beliefs that luckily have kind of going away. Most people aren't stuck on these as much as they potentially used to be, but you have to be careful about that, okay? So one belief that you hear sometimes is that maps are always 100% correct. Okay, we know that's not true, right? Even if the best government agency, or even if you made the map, it's not going to be perfect. Okay, so just because it's in beautiful color and it has the, some government stamp on it, that doesn't mean it's 100% accurate. Also, we sometimes hear that photo interpretation is 100% correct, and that's absolutely not true either. We didn't do a lot of accuracy assessment of photo interpretation early on, but I think we're doing more of that these days. So photo interpretation is not always 100% correct. And, photo interpretation can always be used to assess the accuracy of digital remote sensing classifications. Again, we just talked about that a little bit. No, that's not 100% true. Sometimes if you have some very general classes, you could certainly use, photo interpretation or some kind of image interpretation of some manual interpretation of some digital imagery, and that's commonly done these days. But you have to be careful about that, okay? So just be aware that, there are still some traditional beliefs out there that would kind of cost you some issues. So it add non-error sources of error, right? Not your problems into your data set. So as part of your uncertainty analysis, you'd want to think about these traditional beliefs. Okay, so here's a project. If you've been going through the rest of my lessons, you've seen this example a little bit before. This is the city of Scottsdale. It's a project that we did back in the early 2000s, and it shows you the reasons why we might want to do an accuracy assessment. One, we're doing the project. We want to know how well we're doing. The client, which was the city of Scottsdale for this project, set a contract requirement for us of 85%. We were also using a number of different methods to try to get the best maps. This map was done for water management, mostly stormwater management. And so we used a number of different methods. We used a combined supervised, unsupervised approach. We did some modeling to try to remove some of the error conditions that we were seeing. And we also did some object-based analysis or some segmentation. So we wanted to see which of those three things worked the best. So we wanted to do an accuracy assessment for that. We certainly needed to understand the map errors so that they could be corrected. And we had some confusion between water and dark pavement. We had a little bit of confusion between bare ground and roof. Okay, and so that's where the modeling came in. If we hadn't known about those specific errors through our error matrix, we wouldn't have been able to do this contextual modeling that we did. And then lastly, the city of Scottsdale cared about it the most because they were going to use these maps in their decision-making process, put them into their GIS system for the city of Scottsdale, and use them for stormwater management, for taxation, for land use management, all kinds of things. So there's lots of reasons why you might want to do an accuracy assessment, and this project shows those really, really well. But any project you have should probably have most of these reasons also. Okay. All right, let's make sure we understand the error matrix. So if you looked at my overview presentations, the two lessons that were sort of introductory, you've already seen some of this, but important that we make sure we're all on the same page. So accuracy assessment requires that we select some samples. We're not going to do a wall-to-wall assessment. We're going to do some sampling, and we're going to compare what the map says to what the reference says, right? Okay. And we assume that the reference data is correct, and there's a whole discussion we could have around that. And when we do that, each accuracy assessment sample site will have two components: the reference label, which is assumed to be correct, and the map label. So you can see here that we've got this error matrix that's a contingency table or a cross classification, where on one axis is the reference data and on the other axis is the map data. and you either read across or you read down to see what's going on, right? And so you see that the map said there were 28 forest samples. And when you look at the reference data agrees, yes, 28 times it was forest on the map, and it was also forest on the ground or on the reference data, okay? And 15 times it was water on the map and water on the reference data, okay? But you can see that 5 times it was water on the map, but it was actually urban on the reference data, okay? And then if you take that major diagonal, the ones where you have agreement, so you can see F and F is 28, W and W is 15, U and U is 20. 28 plus 15 plus 20 is 63. There were 100 total samples taken here. 63 divided by 100 is equal to 63%. Okay, so a little review, making sure we're on top of the error matrix. How do we build that? We build it by doing this comparison, right? You've got 2 attributes for each sample. You've got what the map says is going on, and you've got what the reference label says is going on. And so you can see here's that Scottsdale, Arizona map, and you can see we've picked some sample areas. And for instance, sample site 1 is water, okay? And so the map said it was water, and when we went to the reference, it was water as well. So that's a match, right? That would be in the major diagonal. If you look at sample site number 2, the map says it's pavement, but when we went to the reference data, it was actually rooftop. So that would be an off diagonal element. That would be an error off of the major diagonal in your error matrix. Okay, so here's the resulting error matrix from that project. You can see that we have a significant number of samples. We'll talk more about that later on. And then we calculated what's called the producers and users accuracies, as well as the overall accuracy of the classification. You can see there were only 5 categories here, and we've got an overall accuracy of 90%. If you don't remember producers and users accuracies, there is a lesson introducing that in the overview modules, the 2 lessons that were for overview for accuracy assessment. All right. Let's just look at the process. We've talked about this a few different times already, but make sure we're on top of this so that we know what we're going to go through in the next 2 lessons. Okay. So when we assess the thematic map accuracy, we need to think about the sources of error. We've talked about that a lot already, but sources of error or doing some kind of uncertainty analysis, what we want to make sure is that all of our error is due to actual errors in the map so that we can work on correcting those. We don't want non-error differences to be introduced because of other problems that we have, other issues that we have, other things that we haven't considered, okay? So sources of error are important, and you want to consider that. We're then going to talk about classification scheme. Classification scheme is very, very important since thematic accuracy is all about the map classes. Obviously, the classification scheme is key. Collecting the reference data, both for positional accuracy and for thematic accuracy, is the most important thing. It's the most time-consuming thing. It's what needs to be planned out the most. For reference data collection, there's a whole bunch of other considerations. What's the source of my reference data going to be? When do I have to collect it? How do I ensure consistency or objectivity? We're going to talk about those things. Then we'll get into the sampling processes. Okay. For sampling, we have to think about the sample unit now. What size is my sample unit? How big an area am I going to cover? In positional accuracy assessment, it was a point on the ground. Here we've got a unit that actually has area, and very important that we consider that. Then how many samples do we need? Then what sampling scheme, what strategy are we going to use to do the collection, incorporating our thoughts about spatial autocorrelation to make sure we're set on that. Okay, then we get to the error matrix creation itself. So once we have the reference data collected, we have the map, we can go through the process that we just described in the last couple of slides, build the error matrix. There's a bunch of choices here. Are we going to do a single date? We just have a map. We created that map from August 5th, 1992, and we're going to assess that. Or Do we have change detection? And we're going to look at what happened in 2000 compared to what's going on in 2020. Do we need a multi-date or a change detection accuracy assessment, and therefore error matrix? Are we going to do some kind of fuzzy accuracy assessment, and that'll be introduced later on in these lessons? Or are we going to do a traditional error matrix, which we call the deterministic? And then once we have that, we have to calculate the descriptive statistics. That's overall accuracy, producer's accuracy, user's accuracy, things you're already familiar with. And then once we get past that, there are some basic analysis techniques that we can do. There's actually lots of analysis techniques, but two common ones are kappa and marge fit, where we normalize the matrix, or we test whether one error matrix is significantly different than another. Okay, we're going to get all that in the next two lessons. So what did we cover in this lesson? A little summary here. First, we defined thematic accuracy assessment, including some examples so that we all are feeling very comfortable about what we're talking about. Provided a little bit of a discussion about historical perspectives, making sure you understand some historical context, and then how to deal with some traditional beliefs that you might bang into and just want to be aware of. Then we talked about why we do a thematic accuracy assessment. There's 5 reasons for that. Typically, all of them are involved in your assessment, but even if it's just 1 or 2, that's totally fine. We fully explained and documented the error matrix, so that's kind of a review, hopefully, for you. But now you're fully aware and very conversant in what the error matrix is, how you generate it, what's going on with that. Okay. And then lastly, we just looked at the detailed steps that we're going to cover in the next 2 lessons for the assessment process. So stay tuned for the next 2 lessons. Those will be more details about thematic accuracy assessment.